Oh, hi there. Stan Pyler with Electro-Arc out in Ann Arbor, Michigan. In this video presentation today, we're going to review the mechanical magnetic superstructure and the operating instructions for the model 1025 bolt eater. The bolt eater is probably, in fact, one of the easiest machines you'll ever operate. The hardest part is just getting the machine out to the site where the broken fastener is to be removed and getting it set up. After that, it's just point and shoot. It's just that easy. Let's begin by taking a look at the operating panel of the 1025. On the far side, or left side of the operating panel, first we see the cutting power. This is a rotary switch, clockwise, counterclockwise rotation, starting at off, and as the numbers get higher, increases the amount of power to the point of disintegration. These numbers run from 1 to 11. Next is servo feed. Again, a rotary switch starting at 0 and rotating clockwise to a number 10. Servo feed control is used for the speed of disintegration. In the far right corner is our vibration amplitude. Rotary switch starting at 0 and going up to number 10, a maximum vibration. Standard vibration for our head is 120 cycles per second. Back on the left side of the operator's panel, we have a 4 amp which protects our 110 volt circuitry inside the machine. A 15 amp breaker on the outside, a pop type breaker, will monitor the disintegrating circuit or disintegrating transformer. Lower left hand corner, rotary switch on and off for head vibration. Jog switch, this will move the disintegrating head up and down for the initial setup procedure. The amp meter will be used to monitor the amount of current being generated at the point of disintegration. A yellow lighted indicator, power on, will simply indicate or light up when there is in fact power inside the machine. Rotary switch on and off is for our pump. Green illuminated push button is our start button, and finally in the lower right hand corner, our stop button. The bolt eater can be run in 2 modes of operation, the first being manual. For maintenance reasons, we may want to turn on the pump, for example, or start the head vibration and check to make sure that it's operating properly. In this manual mode of operation, there's just a few things we need to do. Let me walk you through these things. For example, we've got the disintegrating head located over the top of the broken tool that's going to be removed. I can manually jog the head up and down, positioning it directly off the top of the broken part. To do this, I'm going to use my jog button. Up and down. Up and down. Next, let's say I wanted to check the head vibration to make sure that it is working properly. In order to do this, I'm going to have to start the machine. And I do that by depressing the green start button. Notice the power illuminator, yellow, has been turned on. With power into the machine, now I can simply turn the head vibration to the on position and adjust the vibration amplitude. Normal settings for the head is generally between 6.5 and 7. Again, we're vibrating at 120 cycles per second at a total traveling distance of about 0.10 of an inch. Next, we're going to check coolant flow. Again, with the machine in the on condition, it's easy enough to rotate the pump on-off switch to the on position. You hear the motor kicking in and coolant is being output at the spindle. The machine can be run in the manual mode of operation. If I wanted to, I could turn on head vibration, coolant pump, and select a cutting heat. At this point, I would be able to downfeed the machine and actually strike an arc. Our magnetic superstructure consists of the following components. We start at the base with our 3,000 pound permanent pull magnet, a 36-inch column with an eye bolt at the top for easy moving the superstructure about, a 16-inch cross arm, quill assembly, and disintegrating head. Off to the back side of the quill assembly or column assembly, we see we have a 12-inch lift rack. This is used for mechanically raising and lowering the superstructure into position. Radial movement is trapped in our quill assembly and locked into place with a mechanical lock. This will lock the elevation of the cross arm and radial movement of that cross arm. In and out movement is locked into place using a locking knob on the outside of the casting back here. A groove has been machined in the underside of our cross arm casting, and a spring-loaded ball is inserted into that casting so that if we were to rotate the head and machine in some other direction, it would be very easy, to find the perpendicularity of the spindle shaft to the work surface by simply rotating the casting until we feel that indentation in the cross arm. Once we've found it, we simply lock it into place. Positioning of this superstructure is quite easy. After we've set the magnetic base into place, now we can bring the head around and locate the electrode directly over the part that we're going to be disintegrating. For demonstrating purposes, we're going to use this 2-inch block of steel and a 3/4 inch square electrode. Before we get into the automatic mode, there's a few considerations that we have to take. For example, what size electrode do I use? What heat setting do I need? How fast can I feed the machine? A lot of this information, is found in our user's guide, which comes with the machine. In that guide, we talk about different applications that we have incurred ourselves, and actually have developed these processes and passed them on for you. For example, taking out bolts, it may require a square electrode or a multitude of several round electrodes. These types of things will have to be decided by you and what is going to work best in your application. To get us started in the automatic mode, we're going to use that 3/4 inch graphite electrode that you've seen in the spindle of our machine, and I'm going to disintegrate a hole down through the 2-inch block steel in the full automatic mode. A couple things that we need to know. Number one, is what heat do I use and what amperage, do I control the feed. Let's take a look at the chart located on the side of your machine. Bolt heater operating guide. It starts off with information on the left-hand side, and it asks questions like, what size electrode are you using and what type? For example, Let's refer back to our 3/4 inch graphite material that we're going to be using in this application. And you look at the fourth column down, it says 3/4 inch square. Coolant pressure, we're going to need 30 pounds. Power cutting is going to be between 5 and 9. Head vibration between 5 and 7. And the amp meter, we should be kicking that thing up around 250 to 350 amps of current. I'm going to start off by selecting the appropriate cutting heat on the face panel. Push in and rotate the knob. I've elected to use heat setting number 6. Again, that was taken from the operator's guide on the side of the machine. Vibration amplitude, they're calling for 7 to 8. Rotating the knob, find a happy medium. How about 7.5? Next, we're going to monitor the coolant pressure, which is a gauge located on the back of the machine. That's going to be at 30 pounds. And then last, we're going to be monitoring the amperage, okay, of the burn, and that's how we adjust the speed. As we start getting into this thing, we're going to start the machine and turn it on, and once I start applying servo control or servo analog out to the drive motor, the head will automatically start feeding down. It will sense the part in advance and slow down and strike an arc. Once it starts to burn, then we'll be monitoring the amp meter, and remember from our chart, okay, it says that I can run that electrode between 250 to 350 amps. So I will continue feeding the servo feed until my amperage gets up to around 300 amps, just to use as an average. And we'll take a look and see how it's burning at that point. So all my settings now are done at the control panel. I'm going to put the servo feed controller back at 0 so there's no surprises, and we're going to go back out to the disintegrating head and finish setting up out there. We've positioned the electrode directly onto our part. I'm going to drop down the splash guard, getting it into position. Drape some rags at the base of the plastic bag just to hold it into place. Adjust my depth stop for 2 inches of travel. That's the actual thickness of the block. And as we feed down, okay, it's going to continue to feed until finally we do hit the depth stop. Before I get started, one of the other things we need to do is relieve all the side pressure out of the spring or the anti-fall device. So, and to do that, I simply pull this button out here, and you hear that anti-fall spring release, so there is no pressure on the head at this time. Next, I want to engage, okay, the auto feed of the machine, and I do that simply by rotating the inner disc, just snugging it up. And at the same time, I'm going to pull that, rotate that knob in the upward direction about 1/4 of an inch, again, so there's no surprises there. So let's get this show on the road. I can either start this machine at the controller itself or from the remote start button located on the top of the head. Okay, the head vibration has been turned to the on position. Our pump is in the on position, and by depressing our remote start button, we'll start the machine. We want to make sure that we have good coolant flow. And now I'm going to step over to the machine and start to feed the servo feed in the downward position by increasing the amplitude. You can see I've got the servo feed controller right at about 2. and my amp meter is bouncing between let's say 250 and 300 amps. We're going to let that settle in for a second here, and then we'll kick that up a bit. Many explosions you hear there are gas is actually being trapped down in the hole as the electrode is striking its arc. At this point, there's not a whole lot for the operator to do. As you can see, the machine is working its way down through the hole. Once that control has been set, the amplitude of the current, the meter itself holds pretty steady. We're pretty much pretty close to 1 inch into the hole. We should be very close to breaking through the bottom of this piece. At that point, we'll stop the machine and turn it sideways and let you take a look at the hole. When you're using graphite electrodes, you can pretty much figure for every 1 inch of steel you remove, you're going to use 1/16 of graphite material. So 2 inches of steel that we've gone through, we should have used about 1/8 of an inch of graphite tubing. Caution when you are using the graphite that the graphite will wear in a cone shape, so you will get a taper in that hole from top to bottom. Breakthrough. We're going to unbury this guy and take a look at him. Let me turn that camera angle a little bit better for you. I was using a core type electrode. So this was what came up through the center. And I don't know if you can see that very well, but there we are, square hole. Should you have any additional questions regarding the volt heater and the performance of this machine, please feel free to contact us in Ann Arbor. Thank you, and we look forward to hearing from you again.